Welcome, guys, to Unit 7, where we're going to really embark on some very new mathematical concepts here. But we are gonna be talking about those new concepts with based on something you already are familiar with, which is trigonometry. In geometry, you worked on right triangle trig, sine, cosine, and tangent. Remember SOHCAHTOA? You worked to use right triangles and those relationships to the trig functions with the opposite side, the adjacent side, the hypotenuse of the triangle, and you use those to solve real life problems and to find angle measures and to find side lengths and things like that of the triangles. Well, what we're going to be doing here now in Unit 7 to introduce to eventually get to our trig function family is start talking about trigonometry outside of just right triangles, but actually start looking at trigonometry with angles that are created essentially by circles. All right, by rotating in a circular fashion. Now, when we do this, we're going to have to kind of redefine what we think about when we think about the word angle, because right now most of you from geometry are very used to angles being part of a shape. A square, a rectangle, a rhombus, a triangle, a trapezoid, right? Angles are fixed measurements in a shape. What we're going to work on now is a brave new world of angles, where angles are not restricted by shapes, but rather defined by rotations, circular rotations around a fixed point. So let's start talking about some new vocabulary that we're going to be using and need to be familiar with. The first one is the initial side. The initial side of an angle in this brave new world is a ray. Remember, just a ray is a I don't know if it's a shape. It's a line, kind of, but it only goes one way, right? It starts at a fixed point and then goes one direction. That's a ray that is fixed along the x-axis. Then you have the terminal side. Right angles still have two sides. The terminal side is the other ray of an angle, and it can rotate around the origin. That's going to be our fixed point, kind of the vertex for all of our angles here. Now, when we talk about an angle being in standard position, what that means is the vertex is the origin, and the initial side is on the positive x-axis. And this is the important word here, positive x-axis. You can draw angles starting with your initial side on the negative x-axis, but just so that we're all on the same page as far as what kind of angles we're working with, standard position is starting on the positive x-axis, right? So a positive angle measure is found by rotating counterclockwise. Now, that's a little bit counterintuitive. We think clockwise positive, counterclockwise negative in terms of time, right? When time is going forward, moving forward positively, the hands on a clock are rotating clockwise. If we were somehow able to reverse time, we always see it in movies where like the hands on the clock go counterclockwise. Well, that's going to be the opposite in our angle measures, and that's because of how our coordinate plane is set up. So let's take a look really quick here at our coordinate plane, right? We have our origin here. So there's the origin. That's going to be the vertex of all of our angles. And what we're going to have here is we're going to have an initial side. Right, so that this ray starting here, this is the initial side, right? And I'll do this in red here so we can kind of color coordinate our vocabulary words with what we see in the picture. This is our initial side. That's where we're always going to start if we're in standard position. Now, what's going to happen, though, is we're going to rotate one of two directions. We're either going to rotate counterclockwise up, if you will, from this angle, or clockwise down. You can see, guys, in our coordinate plane, remember, coordinate plane, the first quadrant is 1, but then as the quadrants kind of increase, as we add 1 to each quadrant, we move counterclockwise to do that. So that is why our angle measures get bigger, increase going counterclockwise, when kind of maybe in our minds we would think it would be clockwise. So we've just got to make sure we lock that fact down. So what happens, I take my initial side, and what's going to happen, I'm going to rotate clockwise here. So I'm just going to rotate clockwise until I get to right there, and that angle is going to stop at what do we want here? What color? We got purple, we'll go pink. All right, red and pink at this side right there. All right, so that would be our terminal side, right? So initial side and terminal side of this angle. Now, because this angle rotated counterclockwise, this would be a positive angle measure, right? This would be a positive angle. If we rotated the other direction, let me grab a different color here. Let's go with sea green here. Let's just say we rotated counterclockwise, right? Well, this is still a terminal side. Whether I go counterclockwise or not, it doesn't really matter. And that looks like 180 degrees. That's neither here nor there at the moment, right? But this angle measure right here would be a negative angle measure because we rotated counterclockwise. So on this, I graphed both, starting with our initial side, a positive angle measure in purple and a negative angle measure in green. And both of these angles, guys, would be in standard position because I started on the positive x-axis and I rotated from there. Now, the one thing we want to also talk about are something called coterminal angles. How many times can you spin in a circle? Well, the answer is, I mean, hypothetically, an unlimited amount. Now, obviously, in real life, you're going to get dizzy and fall down, or, you know, at some point, we're all going to, you know, not be able to spin in circles physically anymore for whatever reason. So we know in real life it's limited, but hypothetically, in math, it's unlimited. We can start at the initial side and I can start rotating around the circle as many times as I want. And here's the deal. If the terminal side, the pink sides of any two angles are the same, because of multiple rotations, we call those angles coterminal angles. All right, let me draw you a quick picture here just so you can see what we're talking about. So here is our, oh, that's really bad. X-axis. There we go. All right, so I'll stick with the same color pattern here. So here's my initial side, right? So I'm going to have a purple angle, and I'm going to rotate to there, all right? And then I'm going to have a terminal side, which I will do in pink. So I have that purple angle measure, and let's just call that purple angle measure. We went 90 degrees, 180 degrees. We'll just call it, for our purposes, 225 degrees. Actually, I'm going to move that out a little bit, just kind of estimating that angle measure. Now, what I can do, and I'll use green because I don't want to get confused. Let's go with gold. All right, is I can now rotate from this initial angle another 360 degrees and end up back where I started. That's the thing about a circle. If you go in a full circle, you end up back where you started. So if I start at the initial side with this gold angle, I hit the initial side, but I keep going. All right, well, what's the measurement of this gold angle? Well, I went 225 degrees to get to the purple, the terminal side here, and then I went another 360. So I have to add the 225 from the purple angle to the 360 rotation that I did, and this purple angle is going to be a 585 degree angle, which I know is like blowing our minds right now because we never dealt with angles in geometry that were bigger than 180 because, well, even 180 because you couldn't have that in a triangle or a shape. But now we've got these enormous angles. And that, guys, this is unlimited. I could go again and add 360 more and add 360 more and add 360 more. These two angles, 225 degrees and 585 degrees, would be considered coterminal angles because even though the measurement is different, where they end, where they terminate is exactly the same. All right. Now, you can get coterminal angles the way we did this by adding 360 degrees. We could also get coterminal angles by subtracting 360 degrees. We can rotate two different directions with our angles here. So if you were asked for a positive coterminal angle, you would keep adding 360 degrees to get a positive coterminal angle. And if you were asked for a negative coterminal angle, you would subtract. So what we see here is that 225 and 585 are coterminal, terminating at the same place, terminal angles. All right. So hopefully that makes sense. We're going to practice this a little bit more later, but that gets us through some of this vocabulary, guys, that is going to be very, very foundational moving forward. So let's start putting some of this vocabulary into place. So 235 degrees. You are asked to draw an angle with a given measure in standard position. So standard position, automatically, anytime you see the words standard position, your initial side has to be right there. So in all of these, since they all have the same directions, now we're not going to do all of them in the notes here. Actually, we'll probably do 3 of them. But you can literally, any problem, guys, that says start with standard position, you can make that initial side and you're done. So now let's talk about the rest of it here. We need this angle to rotate 235 degrees. Well, remember, our right angles still apply, right? Some stuff we learned from geometry still counts here. Each quadrant is made up of a right angle at the origin, which means each quadrant, we kind of talked about it before, is essentially a 90-degree rotation. So if I went from the initial side, don't draw this in, I'm just showing you, to the y-axis here, well, what's that angle measure? Well, clearly that's a right angle. That would be a 90-degree angle, right? Now, again, don't draw that. That's not the answer we're looking for. But that's what we're going to use here, guys, to do this, to get a 235-degree angle. We're just going to have to go a little further. So if I rotate here, it's 90 degrees. So that's 90 degrees. I rotate to the x-axis, the negative x-axis, that's 180 degrees. So then I need to keep going. Now, I'm going to end somewhere in this third quadrant, because if I went another 90 degrees, that would be 270. And one thing that might be helpful, guys, is to label the amount of degrees that each part of the axes of our coordinate plane gets you to, right? That can be very helpful to know where you're at. Notice 0 and 360 are in the same place because you're back where you started. So we can see 235 is going to fall between 180 and 270. Maybe I should have started with this, right? And so that is telling me that somewhere between 180 and 270, I need to have this to have a 235-degree angle. And there we go. We're done. We just drew an angle measure that is 235 degrees in standard position. All right, let's talk about 790. This is where we're going to kind of get into this idea of how we create coterminal angles. Because 790, again, if we label this, right, 90 degrees, 180 degrees, 270 degrees, and 360 degrees, you can see is way off of one rotation around our coordinate plane here. So I'm going to rotate once all the way back to the same initial side. That's 360 degrees. I'm going to rotate again. Well, that's 720 degrees. So I have now covered 720 of the 790 degrees. So the question begs, how much more do I need to rotate to get to 790? Well, 790, I'll just do it over here. 790 minus the 720 I've already rotated leaves me with a 70-degree angle. And so essentially, guys, what we just did is we just found that 790 and 70 are coterminal. All right, they end at the same terminal side. So I'm going to go 70 more degrees somewhere in the first quadrant, closer to 90 than 0, and that would be the end. So this is 790 degrees. Now, again, what I want us to see, just to highlight this coterminal angle idea, right, guys, if I just did that purple angle there would be 70 degrees. Notice they both start at the initial side, they both terminate at this green side, but obviously the 790 is much larger because it made 2 full rotations around the coordinate plane, where the 70 degrees just went 70. It didn't make any full rotations. All right. Now, the 70 is not the big deal here. We want to make sure we graph the 790 because that's what's asked. But again, just this idea of coterminal angles is how we get to understand a 790-degree angle. Let's talk about a negative angle really quick here before we move on, right? So again, negative, the only difference between a positive and negative angle is the direction that you rotate. Positive goes up, negative goes down. So, and the process still applies. Each quadrant is 90 degrees. So when I'm thinking about negative, right, this is negative 90, negative 180, negative 270, and negative 360. 0, it's not positive or negative. So we can see I go negative 90, and negative 150 is going to terminate somewhere right in this range right there. So this would be a negative 150 degrees. And notice, guys, that a negative 150-degree angle, right, is terminating at the same place as a positive 210-degree angle. right? Those would be coterminal angles. So coterminal angles don't just have to have the same sign like we've seen in these examples. You can have coterminal angles where one angle is negative, right? One angle is negative and one angle is positive. Again, don't worry about the 210 in this example. We care about the negative 150, but they're essentially, guys, the same value because they're terminating at the same place. If you want to check your work, the last one here, guys, combines both the idea of a coterminal angle and a negative angle. So try 4 on your own and check a real-time board to get the answer. Let's move on to talking about coterminal angles, guys, more algebraically rather than graphically. So the question becomes, how do we get a coterminal angle from an angle we're given? And the key is, guys, we want to find a positive coterminal angle. Remember, that's we added one full rotation or 360 degrees. And we might have to do that more than once, you're going to see. And a negative where we're subtracting 360. All right, so let's see here, 30 degrees. Well, if I want a positive coterminal angle, right? If I want my positive coterminal angle, I guess I can move this over here a little bit, right? And I want a negative coterminal angle. So both of these angles are going to start with 30, all right? And so now let's add 360, right? And I'll get a measurement of 390. There we go. I now have a positive coterminal angle. Let's subtract 360 degrees. I get negative 330, and that is a negative coterminal angle. And, guys, it's like the transitive property. If 30 and 90 are coterminal angles, and 30 and negative 330 are coterminal angles, 390 and 330 and negative 330 are coterminal angles with each other as well. It's like a family. Every angle, every time you make a revolution, you add one more angle to this coterminal family here. Let's do the same thing here with negative 140. So I want a positive, I want a negative. Both of these are going to start with negative 140. And so I'm going to add 360. And that is going to give me 220 degrees. So there's my positive coterminal angle. I'm going to subtract 360. I'll get negative 500, and there's my negative coterminal angle. Easy peasy. Now, when we get to 760, because 760 is larger than one full rotation, 360 degrees, we are going to have to work multiple times with our adding and subtracting. Maybe not both, but one of them you're going to see here has to be done multiple times to get to change the sign. Since it's positive, adding 360 is easy. That's 10. That's going to be 1120 degrees. So that's a positive coterminal, and we're done. But notice if I subtract 360, guys, that doesn't get me. Subtracting 360 gets me 400 degrees. Well, that's definitely a coterminal angle, but it's still positive, and I want a negative one. So let's subtract 360 again. Let's rotate again. Well, that gets me 40. Still not negative. It's coterminal, but it's not negative. So I'm going to subtract 360 one more time, and now I get negative 320, and that is my negative coterminal angle. So sometimes, guys, algebraically and graphically, you're going to have to rotate or subtract or add 360 multiple times if you're trying to change the sign of the angle measure that you're starting with. All right. Well, next video we're gonna explore radians, the new unit on the block. The good news about the second part of these notes, guys, is what we're actually going to do is completely the same. What's going to change is the unit of measurement we're working with in our angles, and we'll talk about in that video. So I will see you there.